Welcome back, everyone. Listen, the difference between just scraping by with a B and securing that highly coveted A star in Cambridge 9709 mathematics, well, it almost always comes down to one absolutely brutal, highly specific battleground, and that is trigonometry 1.5. Specifically, we're talking about the graphs of sine, cosine, and tangent. Now, today, I am your guild master. We are going to treat this official syllabus like a legendary open world map full of hidden loot and dangerous traps. But we aren't just sitting around talking high-level abstract strategy today. Oh no, we are getting our hands dirty. We're diving deep into actual graph transformations, pinpointing exact period shifts, and mastering those tricky amplitude adjustments to conquer this simulated exam quest. So double-check your inventory, grab your gear, and let's jump right in.
Here's a quick look at our expedition agenda for today. We'll start with the quest board and player profiles, decode the Elder map, get into a co-op raid debate, take a quick mana recharge, jump into the viewer raid world, and finally, hit that victory screen.
All right, Act 1, the quest board and faction profiles. Let's see who's joining us on this raid. To conquer this specific trig dungeon, we're bringing along two co-op players who perfectly, and I mean perfectly, represent the absolute most common cognitive weaknesses that Cambridge examiners see year after year. On the left side of your screen is Alex. Alex is our classic, over-encumbered warrior. They know absolutely every single formula in the textbook, but they have zero agility. When faced with a simple graph sketch, Alex gets bogged down. They meticulously write out every single intermediate coordinate, calculating things pointlessly, and literally draining their stamina bar down to nothing before the timer is even half over. Then, on the right, we've got Sam. Sam is our rogue. Built entirely for high speed, Sam dashes right past mandatory puzzle requirements. Sam tries to just draw the final curve in 5 seconds flat without ever calculating or labeling the critical intersection points on the axes. And let me tell you, neither of these isolated builds will survive what's coming. We need a hybrid strategy.
Moving right along to Act 2, decoding the Elder map.
Okay, I am initiating the first raid phase right now. Imagine a massive, high-tariff trigonometric past paper question has just spawned as our ultimate dungeon boss prompt. To actually defeat it, you have to understand the underlying code of the game, your assessment objective targets. Level 1 is just basic knowledge and understanding. That's knowing the baseline standard shape of a sine or cosine graph. Easy enough, right? Level 2 is application. But Level 3 is analysis and evaluative thinking, and this is exactly where those legendary A-star loot drops are hidden. The Cambridge syllabus heavily emphasizes connected understanding. This means you have to translate that baseline curve accurately. For example, finding the exact phase shift of y equals cosine of x minus pi over 2. And here's the ultimate trap, the command word runes. If you misread the runes, like if you just state the period when the runes specifically commands you to sketch and label, you activate an immediate trap and your mark potential vanishes instantly. So how do we navigate this safely? You need to follow this strict 5-step procedural sequence. Number 1, deconstruct the question completely. Number 2, extract the data. You need to isolate your exact amplitude, your exact period, and your phase shifts before you even think about drawing a single line. Number 3, select your analytical framework. Ask yourself, are we transforming coordinates step by step here, or are we sketching the outer boundaries first? Number 4, execute with crystal clear, undeniable mathematical notation. And finally, number 5, present your final answer using the exact correct terminology. I'm telling you, skipping a step here is literally like stepping on a hidden landmine. You will lose the whole question.
Which brings us to Act 3, the co-op cognitive raid debate. Let's look at the tactical table.
It is incredibly fascinating to watch this clash of strategies unfold live at the table. The stamina bar is aggressively ticking down. I'm listening to them debate, and Alex is stuck in the mud. Alex is trying to calculate 20 individual x and y coordinates just to handle a relatively simple period shift. They're burning precious minutes for absolutely no reason, trying to build this massive wall of overloaded descriptive facts. Sam is on the exact opposite extreme, pacing around, fighting to just draw the transformed curve instantly. Sam is completely skipping the x-axis intersections, ignoring the turning points, and totally rushing the execution. They're furiously debating pacing logic right now. Alex wants total, absolute safety, while Sam wants pure, unadulterated speed. But here's the reality check. The Cambridge mark scheme demands systematic analysis. You have to calculate the key points, yes, but then you sketch smoothly from there. Right now, both of our players are completely off balance. All right, as the guildmaster, I have to step in and intervene here before they fail the run. In the Cambridge ecosystem, you need to think of your save points as your method marks. You are actually awarded marks for showing your mathematical process, mapping out your analytical frameworks, and providing clear annotations, even if your final sketched curve happens to be mathematically slightly off. Cambridge examiners issue a massive, glaring alert about this every single year. Students lose essential marks simply because they don't show their working. If Sam dashes to the end of the dungeon and shifts the graph the wrong way without writing down any calculations, it's game over. 0 marks, nothing to show for it. You absolutely must show your logical, structured reasoning step by step on the page.
Now for Act 4, our mid-quest mana recharge and feeds protocol.
Whoa. Okay, suddenly a huge puzzle roadblock just triggered mid-calculation. Alex and Sam's working just totally dropped its evidence link, and we are now being threatened with a total quest failure. So, quest pause. Before I step in with the ultimate structural blueprint to unlock this top-band mathematical layout and help you conquer your next Cambridge exam, we need to make sure your guild feed is perfectly optimized. Take 1 second right now to subscribe to Ace the Exams and enable all notifications so you never ever miss our weekly strategic map drops, whether you are traversing IGCSE, O-levels, or the treacherous AS and A-level territory. All right? Okay, mana is officially recharged. Let's get right back into the raid. To fix their completely broken logic, we need to quickly review the top 3 fatal mistakes identified directly in the principal examiner reports. These are the traps currently threatening our players. Warning number 1, answers that are vague and lack specific details. Examiners want precise trigonometric coordinates, you guys, not rough, sloppy graphical estimates. Warning number 2, forgetting format and presentation conventions. Your graph needs to look like a math graph, not a modern art piece. And warning number 3, which is a big one, answers that are not specific to the context given. It's actually incredible how often this happens. Think about it. If the question is a real-world scenario about ocean tides modeled by a cosine wave, you can't just leave your answer in abstract radians. You have to relate it back to the actual hours and the actual water levels. So I am handing Alex and Sam the ultimate structural blueprint for pure math evaluation. It's simple. We deconstruct, we solve systematically, and we sketch. Watching them now, they are finally adjusting their working out loud, line by line. First, they identify the maximum and minimum boundaries. Smart move. Then they sketch the transformations systematically, carefully calculating the new period. And most importantly, they state their final coordinates with absolute precision. In trig, skipping something as small as a negative sign on an amplitude shift means the entire graph reflects across the axis. Missing that is an instant, fatal trap. But by following the blueprint, they've just built a perfectly balanced, high-scoring mathematical response.
Let's move to Act 5, the interactive viewer raid world.
All right, now it is your turn to step up. I am turning the tactical HUD completely over to you for a live 60-second diagnostic check. This is Challenge 1, the visual radar sweep. I want you to imagine a 60-second visual countdown timer running right now on a highly complex hypothetical trigonometric dataset. It's showing you amplitude, period, and phase shift trends. Can you extract the single highest yielding core trend from this source data before the grid totally resets? You have to train your eyes to instantly spot whether the amplitude is expanding or the period is compressing, and then you have to be able to articulate that mathematical trend with absolute, unquestionable precision.
Now, moving right into Challenge 2, spot the defective item. I want you to listen really closely to this medium-tier logic pulled from a sample student response. Quote, "The sine graph shift was noted, but no similarities or differences were explicitly compared, and working was completely omitted." Do you notice the exact line where the logic totally drops the mark? I'll point it out right here. The working was completely left out. This is exactly what Sam tried to do earlier. Because the student didn't explicitly calculate and physically show those axis crossings, they completely failed the higher order assessment objectives. They lost the method marks, and subsequently, they lost the final evaluation marks. It's a brutal chain reaction.
And finally, Act 6, the victory screen and expedition outro.
By learning from those exact mistakes, Alex and Sam adjusted their entire strategy. They showed their working clearly, they evaluated the context properly, and the system just registered a successful, full-mark quest compile. They triggered the final trigonometric loot drop sequence. To distill this entire simulation down for your own exams, here are your 3 universal procedural rules. Rule 1, the pre-quest question scan. You must decode the exact command words and transformations before you write a single number down. Rule 2, the stamina pacing matrix. Allocate your time wisely, calculate the key points, but please do not overcalculate every single intermediate coordinate like Alex did. And Rule 3, the post-quest review.
Verify that your sketched curve actually matches the real-world context, and make absolutely sure your method marks are clearly visible on the page.
Remember, if you treat your syllabus like a strategic map, there is absolutely no boss prompt you cannot defeat. So subscribe to Ace the Exams, click that notification bell so you catch our weekly Level Up Masterclasses, and drop a comment below sharing exactly which Cambridge subject and level, whether it's IGCSE, O-Level, AS, or A-Level, you are preparing to conquer next. But before you log off today, I want you to ask yourself a serious question. If Cambridge updated their map tomorrow and completely removed all the formula sheets, would your underlying foundational math, stats, actually be strong enough to survive? Make sure you equip yourself properly, keep grinding, and I will see you in the next expedition.